Okay, so in this video, we're going to go over lesson 3.1, which is the beginning of our z-score unit. Well, maybe. There we go. Okay, so just to recap real quick, all the distributions in Chapter 3 are going to be normal distributions. The z-score formula only works if the distribution is normal. So if they give you a skewed distribution, we actually can't do the following math. But remember that normal, unimodal, and bell-shaped, all three of those words mean the same thing. Another word they could use is symmetric, and all four of those words actually mean the same thing. When we're referring to a normal distribution, remember that the center is mean and the spread is standard deviation. Okay. So you might want to pause it here and write these down. But z-score, the definition of z-score is how many standard deviations a particular data point is away from the mean. Okay, so the z-score is essentially a distance. These down here at the bottom are three different ways to say the same thing. General form is observation minus mean over standard deviation. Or if it's sample data, it's x minus x bar over standard deviation. And in the population data, it's x minus mu over sigma, which is mean and standard deviation. So it doesn't matter which form you're using, really. Mathematically, they're the same. The notation is just slightly different if it's sample or population data. Okay, so now we're going to do three mathematical examples to make sure we're all on the same page. So if I copy the formula down real quick, it's x minus mu over sigma. Remember that the mu means mean, and the sigma, or the weird-looking r, means standard deviation. So when I look at this, it says, what is the z-score of the price of a pair of Jordans that cost $247 if the mean price is $279 with a standard deviation of 16? So if I'm solving for z, I have z equals x is the given data point. So the given data point in this example is 247 minus the mean, which is 279, over standard deviation, which is 16. So you type this in the calculator, and it will tell you that z equals -2. So z in itself in these notes is kind of just a random number. I'm going to write in English like a sentence of what z means. But really, this notes, consider this part 1. In the next video, which is lesson 3.2, goes over how to find probability or proportion based off of z-score. So this, we're just going to talk about how to find the value of this thing called z. And then in the next video, we'll talk about why is this z number helpful. So in English, what this means is the data value is 2 standard deviations below the mean. And I know that it is below the mean because the z-score was negative. All right, next example is basically the same thing, but I've stripped away the context. We're not buying shoes. These are just random numbers, just to make sure we're good with the formula. So to recap, the formula is this. So if I read the question, what is the z-score of a data value of 23 if the mean is 16 and standard deviation is 3? So we have 23 minus 16 over 3. So this is 7 over 3. So z equals 2.33. There's more decimals than that, but with z-score, I'll go over this more in the second video, but z-score, we want to get used to rounding to 2 decimal places, because when we use something called the z-table later, we'll need it rounded to 2. Again, in English, just like the last one, so the z of 2.33 means the data value is 2.33 standard deviations above the mean, And I know it's above because my z was positive. Last example, this is about the only way to try to trick you with z-score is to give you something other than asking for z. So given a distribution with a mean of 60, a standard deviation of 21, find a data value with a z of 2.19. So the formula is z equals x minus mu over sigma. And here, they actually give me z of 2.19. They do not give me x. That's what they're asking for, is what is the data value. They do give me the mean, and they also give me standard deviation. So I know we hopefully all passed algebra, but since we're solving for x, the first step here is actually multiply by 21. And then we add 60. So I find that the x value, or the data value, is 105.99. So again, here we're not solving for z-score, so we're not going to say that it's 105.99 standard deviations above the mean. Remember to pay attention to what you're solving for. Here we're solving for the data value. So this 105.99 is just a number. When you're solving for z, then it's referring to the location.